All right, so today we are continuing on with our lecture series, and we are going to be looking at tool marks and the role that tool marks play in forensic science. Many television shows and even kind of crime scene, or not crime scene, but crime novels will discuss tools that have been left at crime scenes or marks that have been made by different tools at crime scenes. And so, tool mark evidence is going to be or can potentially be a very important piece of information. And so, we want to look at the different types of marks that are made, how those end up being analyzed and compared, the reliability associated with that, among other things. All right, so this section, being able to identify the three major types of tool marks, right, in terms of abrasions and impressions. Those are two of the three that you'll oftentimes find, and then the other is going to be just simply the cutting type of marks as well. But anyway, variations in tool surface, what examiners are going to use to discern between differences of those tools, how it's collected, preserved, and documented. Again, what you're going to find is that there is a lot of overlap in terms of collection and preservation and documentation with regard to tool mark evidence and any other of the other evidence that we've discussed up to this point in time as well. A lot of similar types of tactics. The different types of technology that's being developed today, very, very useful. Um, Again, this removes a lot of the subjectivity, or at least attempts to remove a lot of the subjectivity that's associated with tool mark analysis, make it much more objective in terms of its analysis, therefore more reliable, more repeatable, and obviously better from a um, kind of like a law enforcement type of standpoint. All right. So, in terms of tools, any object that has been created with its major purpose being to make our lives or a particular job or activity that we're doing easier or simpler, that by definition is going to be a tool. Um, and so we have all kinds of tools that have been developed for all different kinds of industries, whether you're talking like home ownership stuff, whether you're talking mechanical stuff, whether you're talking farming stuff, it doesn't really matter. Industrial types of settings, you get the idea. There's lots of different types of tools that exist. And those tools all have very specific purposes that they have originally been designed for. Now, the thing to remember is that as humans, we're a little bit resourceful a lot of the times. And so we've figured out, you know what? In addition to that flat bladed screwdriver being fantastic for turning straight headed screws, I can use it to pry open a can of paint. Works really well for that. I can use it to um, pry apart two pieces of metal that have been stuck together. I can use it to scratch the surface of something else, right? So we have figured out that um, different tools can be used for a wide range of activities. So if you've ever used, I don't know, a crescent wrench and used it to obviously turn a bolt or turn a nut off of a bolt, and then the bolt is a little bit stuck, and so you take that wrench and you tap the bolt to get the bolt to drop out of the hole, right? Obviously, a crescent wrench is not a hammer. A crescent wrench isn't designed to strike the surface of another material, and yet um, we'll use these different tools to do many different jobs. Again, not all of them that they are specifically designed to do, but at the end of the day, they work, and that's what we're attempting to do, right? We're trying to get something to make life a little bit easier at the particular time that we're using it. So that's kind of what that's going to do. Now, what happens is as these tools are used for various jobs in the manufacture of the tools or whatnot, there are going to be very distinctive marks and features that end up being formed on the surfaces of these tools and subsequently on the surface of any material that they come in contact with. So those features, those distinctive features, end up being very, very important to a forensic scientist, to a person that's going to examine those tools and the marks that then in turn are going to make. So the impressions themselves that the tools are going to leave uh, are going to tie a particular tool to a crime scene and potentially be able to lead you back to the owner of that tool. Now, the important thing to remember is just because you find the owner of the tool doesn't mean that that individual is responsible for using the tool in the fashion that it was used. Somebody else could have had possession of it. Um, any number of things are possible. So again, that's something that you have to kind of keep in mind. This kind of goes back to some of the earlier discussions that we'd had in terms of like secondary transfers and things like that. Just because your prints are found at at the scene of a crime doesn't mean that you were the one that committed the crime. You could have been there days or weeks or months before, and whatever it is that you handled never got cleaned or had never been disturbed, and so as a result of that, that your prints potentially could have been found there as well. So the same could be argued for tool marks sometimes, but not always. A lot of the time that we're looking at this is going to be due to that particular individual's direct interaction. Most of the time, almost exclusively, tool marks are going to be circumstantial evidence. Again, the idea that they're going to imply the existence of a fact, but they don't necessarily prove it, right? So if we find a particular set of tool marks on a windowsill of a house that's been broken into, and we find a tool that has marks that match those impressions perfectly, um, while we can link that tool to that crime scene, if they were to find my fingerprints on that tool that left those marks, does that mean that I uh, was the one that used that tool to pry open the window? Not necessarily. Not unless somebody saw me do it, right? If you had a firsthand witness that observed me doing that, but beyond that, it just simply means that I handled that tool. I handled, maybe let's say it's a screwdriver. I handled that screwdriver um, that matched that particular crime scene. So while it doesn't prove that I did it, it's a pretty strong likelihood that I might have been involved in that. Okay, so important to kind of keep that tucked away in the back of your mind as well. All right, so if we look back historically at the history of tool mark analysis, there's really not a lot to it. There are some different events that have taken place, but not a lot that's exceptionally notable. And from a forensic standpoint, this is going to be one of the more relatively recent types of activities that forensics is really getting involved with. And so, because of that, there's a lot that is going on really currently to increase the reliability and accuracy of tool mark analysis, which is a good thing, right? Again, we want that reliability and the accuracy that's going to be associated with that. Much of the tool mark analysis that takes place today is going to kind of fall into that same type of category as what we saw with regard to fingerprinting, and that's going to be those comparison microscopes. And you've got individuals that are going to be trained to discern differences between two very similar materials or two very similar impressions or images or whatever the case might be. So they're going to be very specific things that the examiners are going to be looking for, that will allow them to be able to say yes or no. The image from the crime scene matches the image from the tool that left this mark, right? So again, it does have some subjectivity associated with it, but again, trying to remove as much of that as is possible through various means that we'll talk about as we make our way through this particular lesson. Like I said, it is subjective in terms of the activity itself, and so there is a lot of interpretation that's going to go along with that. So again, some parts that defense attorneys might call into question. But again, if the individual that's presenting the testimony is an expert, that does lend credibility and supports that individual's assessment. So today, what a lot of techniques are going to focus on is getting rid of the general, very vague class characteristics. Okay, we want to dial in or dig in and find those very specific characteristics that are going to individualize the information or the evidence from that particular tool. All right, so you want to get rid of those class characteristics. So individualize it. Again, you can measure today a couple different techniques that we're going to talk about. They're going to be able to create three-dimensional images of the tool that left the marks on whatever the surface was that they were recovered from. So that ends up being very, very important. So again, a much more objective type of process today. Again, increasing the reliability and validity associated with that analysis. All right, and again, from a science standpoint, we like techniques and processes that are going to um, support findings or be able to provide support to findings. I guess might be a better way to look at that. Now, there are some limitations associated with what toolmark examiners can claim, and this is from a governmental database. I don't remember which one I found it in, but it's as recent as 2019. So again, the information it'll change slightly, but as of 2023, these still hold true. So, toolmark examiner cannot say that tool marks that you are comparing originated from the same tool. So the tool that is in question and the tool marks that are in question cannot say that there is no way that that tool mark originated from any other tool. It's a possibility. It's a very slim possibility, let's be very honest, but it is still a possibility. All right. So a tool market examiner can't say there is absolutely no chance that another tool on the face of the planet produced these particular marks. Right. That's basically what this is saying. Can't say that tool mark comparisons are infallible. Right. That means that they are without error and have a zero error rate. We know that's not true. All right, we know that there is a lot of subjectivity still in tool mark analysis. So to say that they cannot make mistakes and there are no errors that are going to be associated with tool mark analysis um, is very erroneous, right, and silly on the part of the person that would make those claims. The last one here shall not provide a conclusion that includes a statistic or numerical degree of probability, right? So you can't say with 99.9% certainty this tool produced this tool mark unless you have some type of other means of being able to produce the numeric values, right? Unless there's some type of statistical value that you can find that's going to be associated with that particular item or that particular process. If you can't find that, then you can't throw out arbitrary numbers. That's providing really some false confidence to anybody that might be listening to your testimony. All right. So when you look at kind of what's involved in tool mark analysis, the basic premise is if you have some type of object, there are going to be some unique and identifying features that will allow you to be able to separate that object from another object very similar to it. So, for example, if I give you two Phillips head screwdrivers, each of those screwdrivers should have some characteristics that would allow you to be able to discern between them. Now, they could be very, very subtle. They may not be something that's visible or noticeable to the naked eye, but in theory, there are differences that exist between them. So with tool mark analysis, what we're looking for is the features that, or are the features, I should say, that the tool is going to leave on the surface that it comes in contact with. most of the time, not all of the time, but most of the time, the tool will be the harder object, and the surface upon which it comes in contact with is going to be the softer surface, right? And as a result, the image or the characteristics of that tool will be left on that softer surface, and that ends up what ends up being analyzed. So as we use tools, we're going to end up creating irregularities. So maybe it's your favorite Phillips head screwdriver. As you use it a lot over and over and over again, you're going to start to find some parts of it will wear unevenly. You may end up with a funny shaped tip on that Phillips head screwdriver because a lot of it'll get worn away as a result of wear and tear. Or maybe you used it to, I don't know, punch a hole in some type of can, and that can gouged part of the blade of that screwdriver, or chipped part of the head of that screwdriver. Right? There's any number of things that potentially could occur. Whether you're talking screwdrivers or knives or hammers or saws or whatever, right? There are going to be a lot of characteristics that end up being generated. So the tool mark examiner is going to look at those microscopic features to be able to discern between the tool and the potential evidence from a crime scene to see um, if they match or if they appear to be from the same source. So tool marks are silent eyewitnesses in criminal investigations, right? Because obviously tools can't tell stories, obviously not via words, but by the um, marks that they leave behind or the marks that are left on them as a result of certain activities. All right, so as we look at tools in crime scene, just because you have a tool that is consistent with one used in a crime does not mean that you were there during that crime. Lots of people have, so let's say you're looking at maybe this is the door that you're investigating, and there are some pry bar marks here on the door, and you have a pry bar. That does that mean that you pried that door open? No, it just simply means that you have a pry bar that a pry bar was used to open this lock. Doesn't mean that you did that. You probably are not the only one with a pry bar. And so for investigators, then they would have to set about trying to show that your particular pry bar matches these marks perfectly, or you had motive, or whatever the case might be. Right? So that ends up being very, very important. As I mentioned earlier, there are three types of tool marks, and so we want to go through those. The first of the three is going to be, or are going to be, those of indentations. Indentations are going to occur when you have a very solid surface coming in contact with a softer surface. Okay. And so, as a result of that, the tool mark impression ends up being made or left behind in that object, in that other object, or in that other surface. So, in this case, it looks like this is probably the claw of a hammer. It could be a tack puller. It could be any number of things. It could even be one end of a pry bar as well. Um, you could end up with the same thing even in metal. Maybe you're prying on something. Maybe there's a fitting over top of a piece of aluminum, and you pry against the aluminum. You're going to end up leaving marks. And you're going to leave indentations that then can be measured. So these can be measured. Lengthwise, you can measure the width. You can make note of the ends of those indentations. Any other unique features that might show up will help to identify or individualize these marks to a particular tool, or vice versa, the tool to these particular marks. So the important thing to remember about these indentations, they are the negative impression of the tool. Right. So eventually, if you need to make an impression of them, you can have that or be able to do that. The second of the types of patterns that are left are going to be the abrasion marks. Uh, Abrasions are going to occur when you have objects slide past one another. So if you've ever fallen down and scuffed your knee on a sidewalk, that's an abrasion. right? Your knee was sliding across the surface of the ground. So the same type of idea. But remember, with abrasions, the harder object is going to leave a mark in the softer object. So if you've fallen off the bike on maybe you're riding your bike and you fall off on a sidewalk, the sidewalk is harder than your skin, and so you end up with those nice little cuts and scuffs that you end up with in our skin. That's the softer surface. Same thing is true with other tools as well. We can see here there was something that had been slid across this door strike plate, and as it did so, it left very unique characteristics associated with it. I mentioned the harder surface on the softer surface. Again, you can have abrasions and indentations simultaneously. All right, you can do that very easily. So if you were to take and slide this, maybe drive a drive a screwdriver underneath a wooden windowsill or window pane, you would end up both with indentations and abrasions, both as a result of the use of that tool. The third one is or are cutting marks. Cutting marks are going to be produced as a result of the tool making marks on the edge of a surface as it cuts through that particular object. All right. And so different saws or different tools will leave different types of um, cut edge surfaces, which ends up being very important. There's a lot of work that's been done and is currently still being done to categorize these and individualize these as well. So, saw blade, type of saw, quality of the saw blade, all of those things are going to in um, basically um, affect the appearance of the cut marks and how well that particular tool is able to accomplish the job. All right. So, in the event that you had someone that tried to dismember an individual, they can look at the cut surface of the bone. Imagine that this is bone and not a piece of tubing of some type. But as a result of that, on the ends of that bone where that saw has run through those bones, you can use that to help determine what type of saw may have been used. Now, the Ames Laboratory in Iowa, we'll actually be talking about that as well here in just a little bit. But the Ames research laboratory, they have started creating a reference catalog of cut marks in bone by different types of saws with different types of blades. It's really pretty astounding some of what they've done. So I believe, if I remember correctly, they've used beef bone and then all the different kinds of saws and saw blades that you can come in contact with. And they've cut through these bones to be able to see what does this cut surface look like and what type of saw did it come from. All right, so again, lots of information trying to get rid of this subjectivity, trying to make it a much more objective type of assessment. So this just gives you some examples of the different types of saws and types of patterns that they may end up generating and kind of what that pattern would look like. So you've got a specific bone saw, the striker bone saw, band saws, common in wood shops. They're common in butcher shops as well. It's how a lot of meat ends up being cut. Hacksaws, common in butcher shops, common in home workshops, common in automotive types of settings. They're, again, very common in lots of different places. But you can go through and kind of look at these um, and just kind of compare and kind of imagine in your mind what types of cuts these types of saws might leave. So as we look at the surface of a tool, each tool is going to end up with unique characteristics as a result of its use or abuse, as the case might be. So when my uh, sons were younger, they would take hammers and they would beat the tar out of screws that had been screwed into a block of wood. Well, obviously, we know you don't hammer in screws, you hammer in nails, but they enjoyed banging on stuff, and so they did. And so I have a number of hammers that the face of that hammer looks a lot like this or a lot like this, where you've got a lot of nicks and dents. The edges are not perfectly round and symmetrical like they used to be. They have shown some definite wear and tear over the years. But again, that individualizes those tools. All right. So in addition to using them as we sharpen tools, um, as we allow those tools to rust or whatever, all of these events help to shape what that tool looks like. And again, for a tool mark examiner, that gives them more criteria, more characteristics, more identifying, very individualizing identifying features for them to be able to point to say, yes, this tool mark and this tool are very, 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 very similar. Dare I even say maybe a match? Okay. So looking at tool mark evidence, again, when you look at tool mark evidence, investigators ideally would love to have both the tool itself as well as the impressions that it ended up creating. Now, that doesn't always end up being the case. The tool marks themselves are almost always recorded, but then ideally you'd like to find the tool that left those marks. But sometimes that can be difficult because not always is the crime scene or the tool left at the crime scene. Right? Sometimes the tool ends up traveling around with the individual that's accused of committing the crime. Um, and then other times they simply the individuals will get rid of those tools. They could throw them into bodies of water. There is a oh goodness, there's a case where there was a gentleman. Now it's not tool marks, but you can envision they do the same thing. A gentleman had taken a he had bludgeoned to death. I think it was his wife, and took the item that they believe was used to commit the crime, and he threw it on top of a shop where he worked down in Florida. And it just so happened by dumb luck that somebody was working up there like 3 months later, 6 months later. It was some period of time, and they found that tool. And they're like, well, that's really weird. Why would that be up here? Well, again, if somebody's trying to dispose of something, you might find a tool in an unusual place. So again, that could be the same with tools discarded from crime scenes as well. So again, there's lots of different ways that or locations that the tool could end up. So in terms of documenting evidence with regard to tool marks, you want to get as much detail as possible, right? So in all of the photographs, like we've talked with other evidence, you're going to photograph it first and foremost. You want to get as much detail as is possible. So you're going to want to show where those tool marks are, the length, the width. Depth would be very difficult, but you can get every all the other pieces of information, and you're going to include obviously a scale ruler, so that it can be used to determine the approximate size of the marks that you're looking at in the pictures. Okay, so again, in the event that it does go to trial, in the event that it is presented in a court of law, you need the information to be as accurate and reliable as is possible. Like I said, provide any close-ups of anything that you may find there. Potentially, there could be other trace evidence that's embedded in those marks, depending upon maybe depending upon how the item was used. So let's say, again, we'll go in the case of someone being dismembered. Maybe they use a saw, and as they're sawing through the individual's limbs and through their clothing, some of the fibers from their clothing are left behind on bone or in muscle or other tissue. Right? That would be trace evidence that you would want to make sure that you have. Right? Because then you could analyze that to be able to make some comparisons as well. You may have to change your lighting a little bit to be able to make that a little bit easier to be able to determine. But in terms of photographing them, right, make molds and impressions of the tool marks. This is done after after you've photographed everything, you've documented it, you've gotten any other trace evidence out of that impression or um, of that tool mark. All right, very important that you get all trace evidence out before you do anything with it. Now, in terms of casting the impressions, much like we talked about with regards to like tire treads and things like that, there's a lot of different ways that you can make molds of these impress or make impressions of these tool marks. This is a few of the different ways that this can be done. Again, each of these will have their very specific applications. It's not a one size fits all. You don't always use Accutrans auto mix casting system. That doesn't make sense. Sometimes that's not going to be your best choice. Um, probably not everything's going to use powdered sulfur. You can see here melted sulfur is poured into impressions in snow, right? So again, it's all going to be varied based on the application that you're going to be applying it. So if you go to cast those impressions, again, you can't use any trace evidence that you want to submit as evidence upon casting of that particular material. All right, so you need to find and remove all trace evidence. So you photographed it. You're going to look very carefully for any other trace evidence that might be left behind. If you find it, you remove it, and then you'll go ahead and cast it. Now, again, depending upon the setting and things like that, you may have to move a little bit quickly so that you don't lose any evidence based on environmental conditions or anything like that. So in terms of collecting and preserving your tool marks, right? You want to be able to package things independently of one another. You would never ever. So let's say this is the strike plate that you removed from the door. You would never package that in the same material as the screwdriver that you think left these little marks on that plate. It's kind of common sense type idea, and yet these are things that have to be taught so people know. So you would package each item separate from one another and separate from any other tools that might be present. Ideally, you want the object itself to be analyzed. So, like a strike plate is very easily removed. It's very easily replaced so that a person could still close and lock their door. But again, you want the original if possible. So maybe if you have a small casement window or something like that, that there's some marks in that you want to be able to analyze. If possible, you would take that window with you to be able to be analyzed most accurately. The basic information, where it was collected from, who collected it, the case, when it was collected, all of that stuff is going to be very important. Okay, and then you would obviously identify on your crime scene drawing where these tool marks were at and where you took the item from. So if there are several doors on a particular location, which door did this come from? Right, that would be very important information. All right. So in terms of being able to analyze that tool mark evidence, again, you don't take if you watch a lot of crime scene shows, they oftentimes will say, "Well, look, this hammer fits the impression in the skull perfectly," and they'll take the hammer and they'll put it into the skull impression. And they're like, "Oh, look, see, it fits." Well, the reality of that is you don't do that, right? Because now potentially you're compromising the shape of that tool mark in the skull, potentially compromising the tool itself. So instead, what's going to be done is you're going to take those casts and impressions, and those are what end up being fit together. Okay, so if you have a hammer that you think was used to bludgeon someone, then you're going to take an impression of the bludgeon marks in the skull. You'll take an impression of the hammer, and you'll see whether or not those two different things fit, if you will, whether or not they go together in a way that you believe is plausible. Serial numbers potentially can be used to identify lots where particular items were sold, like what store maybe it had gone to, and whether it went to a big like home shop or whether it was sold at like a Walmart or something like that. You can get a lot of information from that. Now, the flip side of that is a lot of criminals know that serial numbers are useful, so oftentimes they will remove those. But serial numbers uh, be can be restored to some degree. There's an activity that if you're taking this class in person that we'll be doing where we will attempt to restore serial numbers. Sometimes it's more successful than others, but it's kind of an interesting work in progress. Um, but we'll talk about serial number restoration a little bit later. So the big thing, like we talked about, is removing the subjectivity associated with tool mark analysis. We want it to be very, very objective. And so technology has come a long way at being able to help us to be able to do that. And so the Ames Laboratory in Iowa, they have created a toolmark image database, if you will. And what that does is that allows them to be able to, at least theoretically, um, identify very specifically unique characteristics associated with that tool. All right, so they can see whether or not that tool image shows up from anywhere else. The forensic comparison microscope we've talked about already. You're going to put those two images side by side. And in this case, you notice that the striations match up beautifully. So if one of these items, let's say the item on the left is from the crime scene, and the image on the right is from the from the tool itself, you can see that the two images are um, they fit together very, very nicely. So this would very strongly suggest that this tool left this mark at that particular location, right? So again, can use it in that type of fashion. Again, being able to create three-dimensional topography of a particular tool mark, again, becomes very important and very useful in terms of identifying unique features of that tool mark. Okay. Again, trying to reduce the subjective nature of that. Right. Again, objectivity is very, very, very good. So in terms of the courtroom, they're going to oftentimes take, if you have maybe some type of oh goodness, some type of assault, and you've got maybe a screwdriver that was used to stab someone, and that screwdriver maybe hit bone as the individual defended themselves or whatever. They will take that screwdriver with them, and to be able to show this is the object that created the wound. Here is the cast of the tool. Here's the cast of the wound, and you'll notice that these fit or match up very, very closely. Okay, so you present that as oftentimes as possible. Casts and images of the tool mark are going to be very, very important. So again, you're going to want to identify where those came from, because again, that ends up being part of that chain of custody and the evidentiary value associated with that. Okay. Again, as this technology improves, um, your toolmark examiners will become better and better at being objective in terms of their assessments, and their analysis will become more and more accurate over time as well. So, advances in Toolmark, obviously, traditionally, they've used visual wear pattern recognition. So again, we're basing it on the naked eye, even microscopic examination. But again, we're getting rid of those class characteristics, trying to find individual uniqueness associated with each tool. There have been a number of cases that have challenged that. Um, But, the one that I'm referencing here, there was a knife that was used, I think, in an attack of some variety, and, one of the experts said that that knife, the wear pattern of the knife matched up with the wounds or with the, uh, marks that were left, at the crime scene, and, basically that the defense was able to create enough doubt that there wasn't enough scientific evidence to support just visual wear pattern analysis as being the standalone means of um, determining guilt. Basically, it was kind of impressive. But anyhow, the tooled image database that the Ames laboratory has created from lots of different types of tools to be able to show kind of some of the marks that end up being made, very, very important. um, and so now they forensic examiners or tool mark examiners have the ability to submit images from the comparison microscope, and they can feed this into the computer, and that computer using AI is able to determine the relatedness of the two different images. So do they match, or are they very close to one another, or are they very, very different? So again, it just saves a person from having to go through and look at hundreds of thousands of millions of different images. One of the newer things is the profilometer, and this tool allows scientists to scan and then create a contour map, a topography, if you will, of a tool mark, um, and then they can do the same thing with the tool to see whether or not the mark, or the tool pattern itself and the tool, whether or not those two images or those two patterns look like they belong together. So again, creating a lot more objective measurements and things that can be repeated over and over again. So this is a profilometer that I was talking about just a second ago. I'm not familiar with it directly, but again, you could see how it's able to maybe determine what the shape of a particular material is or whatever. So anyhow, that is our lecture on tool marks and tool mark analysis, collection, preservation, and all that good stuff. If you have any questions, make sure you reach out to me. Otherwise, I will talk to you soon.